In this video, I'm going to show you what is an exact differential equation and how we can solve this type of differential equations. A differential equation in the form of m of x and y dx plus n of x and y dy equals 0 is an exact differential equation if derivative of the function m, note that here m is a function of x and y and n is also a function of x and y. These type of differential equations are exact differential equations if derivative of m, note that m is the coefficient of dx, if derivative of m with respect to y equals derivative of n with respect to x. So if derivative of m to y equals the partial derivative of n with respect to x, then we say the differential equation is exact differential equation. And again, note that we take derivative of coefficient of dx with respect to y, but we take derivative of the coefficient of dy with respect to x. And if these two be equal to each other, then we say the differential equation is exact differential equation. Solving this type of differential equations involves many steps, and I will show you by some examples how we can solve this type of differential equations. Also in this video, I will show you a shortcut method for solving this type of differential equations. Our first example here is y cosine of x plus 2x e to the y dx plus sine of x plus x squared e to the y minus 1 dy equals 0. The first thing that we have to do here is to make sure that this differential equation is an exact differential equation. In this example, this expression is m. Note that m is the coefficient of dx and this expression is coefficient of dx. So m in this example is this expression and n, the other function, is the other bracket. This bracket is m and this bracket is n. Derivative, the partial derivative of m with respect to y is cosine of x. Note that for finding the derivative of this expression with respect to y, we consider cosine of x as a constant and we just take the derivative of y because we are taking derivative with respect to y. So we consider cosine of x as a constant and the derivative of y is 1. So 1 times cosine of x is cosine of x plus, now we have to find the partial derivative of 2x times e to the y. Here 2x again is like a constant and we have to take the derivative of e to the y because we are taking the derivative with respect to y, and the derivative of e to the y is e to the y. So the partial derivative of m with respect to y is cosine of x plus 2x e to the y. Now we have to find the partial derivative of n with respect to x. Derivative of sine of x with respect to x is cosine of x. Derivative of x squared e to the y is 2x e to the y. We are taking the derivative of x2, which is 2x, and we just write e to the y. And derivative of the constant -1 is 0. And as you can see here, these two expressions are equal to each other. And because they are equal to each other, so it shows that this differential equation is an exact differential equation. Now that we know this differential equation is an exact differential equation, we have to solve this differential equation. The first step for solving an exact differential equation is to find the integral of m with respect to x. So the first step for finding the function f, the function that satisfies this differential equation, is to find the integral of m dx. So here in this example we have to find integral of y cosine of x plus 2x times e to the y with respect to x. Because we want to find integral of this expression with respect to x, y here is a coefficient, is a constant for cosine of x, and we know that integral of cosine of x is sine of x. So integral of y cosine of x is y sine of x plus integral of 2x times e to the y. Here note that e to the y for 2x is a constant, is a coefficient. We are taking integral with respect to x. And integral of 2x is x squared because the derivative of x squared is 2x. So integral of 2x times e to the y is x squared e to the y. Always when we are finding indefinite integrals, we add a constant or answer. But here note that with respect to x, any function that involves only y variable can be considered as a constant. So instead of adding only a c here, we have to add always a function in terms of y in our answer. Note that if we take derivative of this function with respect to x, derivative of this expression is 0 because everything in this expression involves y and there is no x, no variable x here, and so derivative of this with respect to x is 0, so we can add gy as a constant to our answer. This is what you have to do always in solving exact differential equations at this step. Don't forget, when you integrate m, in your answer add a gy. And this gy plays the role of a constant for the integral. For finding this unknown function g, if we take derivative of all of this expression with respect to y, the derivative of this expression must be equal to n. So for finding g here, if we take derivative of this expression with respect to y, the derivative of this expression should equal to n, the expression here. So the next step in solving the exact differential equations is to take derivative of this expression with respect to y. Derivative of y sine of x with respect to y is sine of x. Don't forget, we are taking derivative of this with respect to y. So derivative of y is 1 and sine of x is a constant because we are taking the partial derivative with respect to y. Derivative of x squared e to the y with respect to y is, write the constant x2 and take derivative of e to the y, which is e to the y. And derivative of g of y is g prime of y. And this should equal to n, which is sine of x plus x squared e to the y minus 1. Now if you look to the left side and right side of this equation, you can see that sine of x in the left side with sine of x in the right side can cancel each other. X squared e to the y and x squared e to the y also cancel each other. And so g prime of y equals -1. Now here, for finding the function g from this equation, g prime of y, the derivative of the function g, is -1. And so for finding the function g, we have to integrate from this expression. An integral of -1 with respect to y, note that g prime of y, so the variable is y. An integral of -1 dy is -y. So g of y is -y. Now that we know the function g is -y, if we replace g here with -y, we can write the solution of this exact differential equation as y sine of x plus x squared e to the y minus y equals a constant like c. And this is the implicit solution for this differential equation. So this is the answer of the question. Let's review the process of finding the solution of an exact differential equation. The first step is to integrate m, the coefficient of dx, with respect to x. So first here we are finding the integral of m, which in this example is this expression, with respect to x. And when we are finding the integral, instead of putting a constant c in the integral, we add a function, an unknown function like gy, instead of the constant. Because with respect to x, because here we are integrating with respect to x, g of y is a constant because everything here is dependent to y. And with respect to x, g of y is a constant. So we add a g of y to our integral. For finding this g, we have to differentiate this and set it equal to n here. So for finding g of y, take the derivative of this expression with respect to y and set it equal to n, as we did here. Then for finding g of y, you have to integrate from g prime of y to find g of y. After you find g of y, you can substitute g of y with the expression that you find here, and you can write your solution. Before doing the next example, let me show you the shortcut method for solving exact differential equations. The differential equation was y cosine x plus 2x e to the y dx plus sine of x plus x squared e to the y minus 1 dy equal 0. In this differential equation, m is y cosine x plus 2x e to the y, and this expression is n. We can use this formula for finding the solution of exact differential equation. Integral of m, this expression, with respect to x, plus integral of n star dy equals c. So, for finding the solution, integrate all the terms in m, everything here, with respect to x, plus integral of not all the terms in n. By n star, I mean only the terms in n that are not a function of x that are independent to x. So n star is not all the terms in n, it's only the terms that are not a function of x. For example, here sine of x involves x, so we ignore this term, and also we ignore this term because in this term we have x. But in negative 1 we don't have any x, so we integrate only negative 1 here with respect to y. So n star is only the terms in n that are not a function of x. So based on this formula, if we want to solve this exact differential equation, our answer is integral of all of these terms. So integral of y cosine of x plus 2x e to the y dx plus integral of only negative 1 dy equals c. By finding these integrals, we can find the solution. Integral of y cosine of x with respect to x is y sine of x. Integral of 2x e to the y with respect to x is x squared e to the y. And integral of negative 1 with respect to y is negative y equals c. And this is the implicit solution of this exact differential equation. If you compare this answer with the answer we found here, you can see that the answers are the same. Now let's do another example. 2x plus y dx plus x plus 3y squared dy equals 0. This expression here is m and this expression is n. First we have to check to see if this differential equation is an exact differential equation. We have to find partial derivative of m with respect to y and the partial derivative of n with respect to x. Derivative of 2x plus y with respect to y is 1. Note that we are taking derivative of this expression with respect to y. So derivative of 2x with respect to y is 0 because we consider y the variable. So 2x is constant with respect to y. And derivative of any constant is 0. Derivative of y is 1. Derivative of n, the partial derivative of n with respect to x is also 1. Because derivative of x is 1 and derivative of 3y squared with respect to x is 0. And so derivative of n with respect to x is also 1. And because partial derivative of m with respect to x equals partial derivative of n with respect to y here equals partial derivative of n with respect to x, so the differential equation is an exact differential equation. For finding the solution of this exact differential equation, again the first step is to integrate m with respect to x. Integral of 2x plus y dx. Integral of 2x with respect to x is 2 times x squared over 2, which is x squared. And integral of y with respect to x is yx. Note that because we integrate with respect to x, y is a constant. And integral of y with respect to x is yx. For example, if you think y as 5, integral of 5 dx is 5x. And so integral of y dx is yx. And don't forget, you have to add an unknown function in terms of y here as a constant of the integral. for finding this g here, if we take derivative of this answer with respect to y, it should equal to n. So we have to take derivative of this expression with respect to y. Derivative of x squared with respect to y is 0. Derivative of yx with respect to y is x, and derivative of gy is g prime of y. If we set this equal n, which is x plus 3y squared, x from here and x from here cancel each other, so we get g prime of y is 3y squared. And for finding g, we have to integrate this expression with respect to y. And integral of 3y squared is integral of 3y squared with respect to y is 3 times y to the 3 over 3. And if we cancel 3 with 3, we have y to the 3. So g of y is y to the 3. Now if we plug in this for g, we get x squared plus yx plus y to the 3 equals c as the solution of our differential equation here. And if you want, of course, you can use the shortcut method for finding this answer. Let me show you the shortcut method here also for this question. The differential equation was 2x plus y dx plus x plus 3y squared dy equal 0. Because this differential equation is an exact differential equation, we can use that shortcut method for finding the solution. Here, this expression is m and this expression is n. The formula was integrate everything in m with respect to x and integrate only the terms in n which are not a function of x. Ignore the terms with x and only integrate the terms without x with respect to y, which means that the answer is integrate 2x plus y dx plus integrate. Here we have two terms in n, x and 3y squared. X is a function of x. Here we have x, so we ignore this term. But in 3y squared, everything is in terms of y. We don't have any x, so we have to integrate only 3y squared dy and equal c. Integral of 2x plus y with respect to x is x squared plus yx. And integral of 3y2 with respect to y is y to the 3 equals c. And so this is the implicit solution of this differential equation. The next differential equation is 3x squared plus y cosine of x plus sine of x minus 4y to the power of 3 y prime equals 0. Note that this given differential equation is not in the form of Mdx plus Ndy equals 0. We don't have any dx and dy. This form is the differential form of a differential equation. But in this given form here, we don't have any dx or dy. Simply, if we replace y prime here with dy over dx, and if we multiply both sides by dx, we can write this differential equation in the form of 3x squared plus y cosine of x dx plus sine of x minus 4y to the 3 dy equal 0. Now the differential equation is in the differential form, or in a more symmetric form. We have a function of x and y, which is m dx, and a function of x and y, which is n dy, equal 0. Now, first we have to check to see if this is an exact differential equation or not. The partial derivative of m with respect to y is, note that this expression, derivative of 3x2 with respect to y is 0, and derivative of y cosine of x with respect to y is cosine x. And the partial derivative of n, this expression, with respect to x is also cosine of x, because derivative of sine of x with respect to x is cosine of x, and derivative of 4y to the 3 with respect to x is 0. So the partial derivative of n with respect to x is the same expression. And because the partial derivative of n with respect to x equals the partial derivative of m with respect to y, so the given differential equation is an exact differential equation. Now, for finding the solution of this exact differential equation, as usual, first we have to integrate m with respect to x. M here is 3x squared plus y cosine of x dx. The integral of 3x squared is 3 times x to the 3 over 3. And if we cancel 3 with 3 here, so it equals x to the 3. And integral of y cosine of x with respect to x, y is a constant, we write the constant, and we integrate cosine of x. And integral of cosine is sine of x. Don't forget you have to add g of y here as the constant of the integral. For finding g, again we have to take derivative of this with respect to y. Derivative of x to the 3 with respect to y is 0. Derivative of y sine of x with respect to y is sine of x. Because derivative of y is 1, and we have 1 sine of x plus g prime of y. And this should equal to n, which is sine of x minus 4y to the 3. From here, because sine of x and sine of x cancel each other, g prime of y is negative 4y to the 3. If we integrate to find g, the integral of negative 4y to the 3 is negative y to the 4. And so the implicit solution of the differential equation is x to the power of 3 plus y sine of x minus y to the 4. We replace g with this expression, equal c. And so this is the solution of this exact differential equation. And the other way you can find this answer is to use the shortcut method. Let me show you how you can use the shortcut method to find this answer. For finding the solution of this differential equation, we have to integrate m, which is 3x squared plus y cosine of x with respect to x plus integral of the terms in n that are not a function of x. So we ignore this term and we have to integrate only negative 4y to the 3 dy equal c. The integral of 3x squared is x to the 3. Integral of y cosine of x with respect to x is y sine of x. And integral of negative 4y to the 3 is negative y to the 4 equal c. So as you can see, with the shortcut method you can find the answer easier. Here the question is find the value of a that makes this differential equation an exact differential equation, and then solve the differential equation. X plus ay dx plus y plus 4x dy equals 0. So we want to find the value of a that makes this given differential equation an exact differential equation, and then we want to solve the differential equation. We know that a differential equation is an exact differential equation if the partial derivative of m with respect to y equals the partial derivative of n with respect to x. The partial derivative of m with respect to y equals derivative of x is 0 with respect to y, and derivative of ay with respect to y is a. The partial derivative of n with respect to x is the partial derivative of y with respect to x is 0, and the derivative of 4x with respect to x is 4. So the differential equation is an exact differential equation if these two values be equal to each other. So a must be equal 4. Now if we plug in 4 for a here, the differential equation is x plus 4y dx plus y plus 4x dy equal 0. Note that here this expression is m and this expression is n. For solving this exact differential equation, as usual, first we have to integrate m with respect to x. Integral of x plus 4y dx is equal to x squared over 2 plus 4yx. And don't forget to add gy here. Now for finding g of y, if we take the derivative of this with respect to y, it should equal to n. Derivative of x squared over 2 with respect to y is 0. And the derivative of 4yx with respect to y is 4x. And the derivative of g of y is g prime of y. And it should equal n, which is y plus 4x. Now here, if we cancel 4x with 4x from the two sides of the equation, g prime of y equals y, and so g of y is y squared over 2. Note that if we integrate y, integral of y is y squared over 2, and so g of y is y squared over 2. Now if we plug in y squared over 2 for g, the solution of the differential equation is x squared over 2 plus 4yx plus y squared over 2 equal a constant like c. And so this is the solution of this exact differential equation. Another way that we can find this solution is to use the shortcut method. Based on the shortcut method, we have to integrate m, which is x plus 4y dx, and from n, from this expression, we only integrate the terms here that are without x. So we only integrate y. and we ignore the other term 4x. So we have to integrate y with respect to y, and we have to set it equal to constant like c. Integral of x with respect to x, integral of x dx, is x squared over 2. Integral of 4y with respect to x is 4yx. And finally, integral of y is y squared over 2. So with the shortcut method, we can find this answer faster and, of course, easier. I hope by watching this video, you have learned what are exact differential equations, how we can check to see if a differential equation is an exact differential equation, and also I hope you have learned how to solve exact differential equations. If you liked this video, please subscribe in my channel and see you in the next videos.